Good morning. As you can see, I'm not there today. I'm not feeling well. I do believe my substitute is Mrs. Robinson, so please give her all and more of the respect that you would give me if I was there today. We just finished a unit on transformations, and now we're going to go back into Chapter 9, where earlier this year we had worked on scatter plots, and we're going to explore probability. Probability is one of my favorite things to teach. It's the study of chance. Has a lot to do with gambling, although our book would never tell you that, but it does. Lottos, drawings, things like that. It's also one of the reasons I don't gamble because I understand the mathematics behind it. But first thing you got to do is you got to be able to find the sample space. And if you go to page IN20, which is, you got to go to page 674. These are special sections in our book, so turn to page 674 and then go 2 pages past that to page IN20. And you will see it looks like this, and it says find a sample space. Now the sample space sounds real important, well, because it is. It's the set of all the possible outcomes in a probability experiment. Okay, and you're like, experiment? Yeah, probability experiment. When we play a game, when, if you're flipping channels and all of a sudden you see Texas Hold'em poker tournaments on, which are on all the time, those little percents come up. They're keeping track of the sample space, cards that have been played, cards that are still left. That's how they can tell you who's got the best chance of winning. Now you can find the sample space. You're just going to make a list of everything that can happen. Now don't worry, we're not going to do that with a deck of cards. That would be almost ridiculous. It would be very big for you now. One day, but not today. You'll learn that. Organized lists, tables, and tree diagrams can be used to represent the sample space. Sometimes you can make a list, organized list. It's short, it's easy to do. Other times it's easier to draw a table or a tree diagram just to make sure you didn't forget anything. And it doesn't take long. And in another day or two, I'll show you another way to find the number of things in the sample space, because that's really what we're after. Okay, if you look, first example, it says the number of students chosen to represent Mr. Baldrick's class in a school assembly are shown. All three of them need to sit in a row on the stage. Use a list to find a sample space for the different ways they can sit in a row. Now, your book runs through this, but let's just use the first letter in each of their names. Now, they could sit like this, just the order they're in. You could have, try to keep this small over here, Adrian and then Carlos and then Greg, all right? Now, if Adrian stays in the first seat, who else could we switch? We could switch Greg with Carlos. Now we got two. Are there any more ways for Adrian to sit in the first seat? No, there's not. So let's put Carlos in the first seat. We'll put Carlos there, and then you could have Adrian and Greg. Leave Carlos there. You could have Carlos and then Greg, then Anthony. All right, well, any more we could have Carlos be first? Nope, there's not. So the only person who hasn't sat in the first seat is Greg. So we could have Greg, then Adrian, then Carlos. Or if we switch Carlos and Adrian, we could have Greg, then Carlos, then Adrian. And I can't think of any other ways to do that. Can you? Now, we just made an organized list. This is our sample space. How many ways can they sit in those three chairs? 1, 2, 3, 4, 5, 6. There's 6 ways, and there's a list of them all. Adrian, Carlos, Greg, Adrian, Greg, Carlos, Carlos, Adrian, Greg, Carlos, Greg, Adrian, Greg, Adrian, Carlos, Greg, Carlos, Adrian. There they are. 6. That's the sample space. The list of every way we could sit them. That's all the sample space is. Now, if you go a little further down the page, they talk about this. You got to read this problem. This is, you guys are going to have to do a little reading today. A car can be purchased in blue, silver, red, or purple. It also comes as a convertible or hardtop. Use a table or a tree diagram to find the sample space for the different styles to which the car can be purchased. So first they did a table. Now think about it. You can get a blue convertible or a blue hardtop. That's it for blue. You can get silver convertible, silver hardtop. That's it for silver. Red convertible, red hardtop. Purple convertible, purple hardtop. 1, 2, 3, 4, 5, 6, 7, 8. 8 different things in the sample space. Now, here they use a tree diagram. It's basically the same. You can go sideways or you can go up and down. I like up and down a lot. Since March Madness is just about over, right out in the hall, we have a huge tree diagram, except instead of starting small and getting bigger, it started bigger and it's getting small, because we're down to 4 teams left. Okay, so look, blue convertible, blue hardtop, same thing we saw there. Sample space, they're just abbreviating, saves you some writing. Silver convertible, silver hardtop, red convertible, red hardtop, purple convertible, purple hardtop. There's 8 outcomes. If they ask you to list the sample space, that means write down what could happen. You can abbreviate or you can write it out. It's really not difficult. You just have to be organized as you try to figure it out. Exhaust all possibilities for the first category before moving on to a different color in this case. All right, so let's take a look here. The table shows the sandwich choices for a picnic. Find the sample space using a list, table, or tree diagram for a sandwich consisting of one type of meat and one type of bread. Well, okay, we got meat. We got ham and turkey. Okay, so we could easily just make a tree diagram. We got ham, turkey. All right, now how many different types of bread could you put your ham on? Yeah, there's 3. 1, 2, 3. And those are, oops, where's my pen go? And those are rye, sourdough, and white. And then the same goes for turkey. You can have turkey on rye, turkey on sourdough, turkey on white. Okay, not a very difficult tree diagram. There's 6 things. You just read down it. Ham on rye, ham on sourdough, ham on white. Turkey on rye, turkey on sourdough, turkey on white. Simply put, there it is. Now, this is going to take us a little bit further because if you turn to the next page, it then talks about finding the probability of a compound event. And a compound event consists of 2 or more simple events. The probability of a compound event, just as with simple events, is the fraction of outcomes in the sample space for which the compound event occurs. It's basically simply like this. It's a fraction where on top you have basically, let's just go up here, number of favorable outcomes. Let's make that line bigger. Over all of the possible outcomes. And since it's a fraction, it can be turned into a decimal, it can be turned into a percent, and it's a fraction, it's always between 0 and 1. 1 means it's guaranteed to happen, 0 means it'll never happen. Okay? So what we have to do is we're going to be asked a question about a couple of events. We'll first figure out everything that can happen, and then we'll figure out the ways, what we want to happen, ways we can win, favorable outcomes. Okay? Think about this. What's the sample space for flipping a coin? There's 2 things that can happen. You get heads or tails. So the sample space for flipping a coin is 2. And this is a single event, not a compound event. So what's the probability that it'll land on heads? Well, heads would be our favorable outcome. There's 1 way it can land on heads out of 2 possible outcomes. Now I'm going to take it further and blow your mind up a little bit. Okay, further down the page. Suppose you flip a quarter, a dime, and a nickel. Find the sample space, then what's the probability of all 3 tails? So look, you flip a quarter, you can get heads or tails. Then you flip the dime, you get heads, and then heads, or heads and tails. See the tree diagram? Or tails and heads, tails and tails. And then the nickel, you get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. Now, how many things can happen here? 1, 2, 3, 4, 5, 6, 7, 8. So the total number of outcomes is 8. Okay? So that's our total number of outcomes. 8 different things that happen when you flip all 3 coins. How many of them are favorable? What did we want to see happen? 3 tails. How many ways can you get all 3 tails? 1. So if you flip 3 coins, your chance of getting it to land on all 3 coins to land on tails is 1 out of 8, which means you got a very low chance of winning and a much higher chance of losing. Okay, that's how we do that. Just got to make your diagram, go from there. All right, so look, let's take a look. You go to the animal shelter, they have both male and female Labrador retrievers in yellow, brown, or black. There's an equal number of each kind. What's the probability of choosing a female yellow Labrador retriever? Show your work in the space below. Well, look what it says over here. When you're choosing an outcome, assume each outcome is chosen randomly. So you can't say, well, I only like black Labradors. No, it's got nothing to do with that. Okay, we're just, if we closed our eyes and snatched up a dog, what's the chance it'll be female yellow lab? Okay, so what do we know first? Well, we've got 2 types of dogs here, 2 types of Labradors. We got the males and the females, right? And then we also know there's 3 colors. All right, 3 colors for each. So if we go deal with that, we got, okay, yellow, brown, oops, it's supposed to be there, black. We got yellow, brown, and black. So how many possible outcomes are there? Well, there's 6. Male yellow, male brown, male black, female yellow, female brown, 4, 4, 4, and female black. So there's 6 things that can happen. How many of them are favorable? How many of them are yellow and female? That's what we want to happen. There's only one way to do that. So the probability of that happening is 1 out of 6. Okay, so the chance you randomly pick a female yellow lab is 1 out of 6. Okay, now go to the next page, Indiana 22. Same thing, carnival games. You know, you go to the fair and they got all them dudes showing you how easy it is and that you can never win because the basketball's overinflated and the rim's half the size they're supposed to be. So to win a carnival prize, you need to choose one of 3 doors labeled 1 through 3, and then you need to choose a red door, a red, yellow, or blue box behind each door. What's the probability that the prize is in a blue or yellow box behind door 2? So first, everything can happen. They made a table this time. Door 1, red box. Door 1, yellow. Door 1, blue. Okay? Behind in door 2, there's going to be a red box. Door 2 is going to have a yellow. Door 2 is going to have blue. Door 3 would have red. Door 3 would have yellow. Door 3 would have blue. So there's 9 different things. Okay? Now, how many of those are favorable? Well, to win, what do you need? You need a blue or yellow. You want to see if it's blue or yellow, and it's behind door 2. So there's 1, 2 ways to do that. So the probability would be 2 out of 9. Okay? Really pretty straightforward. So, here's what we've got for the rest of the day. On pages Indiana 23 to pages Indiana 25, problems 1 to 14. You have plenty of time. Probably close to a half hour to get this done in class. You might have to make a few tables, not the end of the world, or a couple tree diagrams. It's not going to kill you. You know, the first 4, they just want to know find the sample space. So if you toss a coin, what can happen when you toss a coin? Well, you can get it on heads or tails, right? Then the spinner could land on 1, 2, 3, 4. Pardon my writing, it's horrible. 5. Tails 1, tails 2, tails 3, tails 4, and tails 5. So how many things can happen? There's 10 items in your sample space. That's all they want. They don't want probability, they just want to know. What are they? You can make a list. Heads 1, heads 2, heads 3, heads 4, heads 5. Tails 1, tails 2, tails 3, tails 4, tails 5. Whew. So there you go. Have a great day. Hopefully I'll see you tomorrow.